One main concept of this chapter is to find out the relationship of the angles between two parallel lines. The theorems are related to corresponding angles, alternate angles, and interior angles on the same side. We can use three letters to help us to remember these angles. We can use F for corresponding angles, Z for alternate angles, and C for interior angles on the same side. First, we will talk about corresponding angles. Refer to the diagram with a pair of parallel lines. We just said we can use F to remember corresponding angles. Let me draw a F on the diagram. These two angles in blue are a pair of corresponding angles. Under the condition of parallel lines, this pair of corresponding angles are equal. You may imagine us translating this angle up and down. Obviously, we can flip this F laterally or upside down. The situations will be like these. This one is just like the number 7. This one is just like rotating the F by 180 degrees. This one is just like flipping the F upside down. These figures are examples of corresponding angles. For alternate angles, we will use the letter Z to help. Let's look at this example. These two angles are alternate angles. Under the condition of parallel lines, this pair of alternate angles are equal. Similar to the situation of corresponding angles, we can flip this Z laterally or upside down. We can also rotate this Z through 90 degrees, which becomes a letter N, or a laterally inverted N. The most important point is also under the condition of parallel lines. This pair of alternate angles are equal. Finally, for interior angles on the same side, we will use the letter C to help. This pair of angles is a pair of interior angles on the same side. But notice that, under the condition of parallel lines, this situation is different from that of corresponding angles and alternate angles. This pair of angles are not the same. Instead, the sum of this pair of angles is 180 degrees. Normally, we can use letter C to help. We can also rotate this C through 90 degrees, which becomes a letter U. Remember these letters if you are confused with corresponding angles, alternate angles and interior angles on the same side. One difficult part in this chapter is that most of the students do not know how to use the converse of the previous three theorems. They are corresponding angles equal, alternate angles equal, and interior angles supplementary. These three theorems will only be used when proving two lines are parallel. Take this as an example. We have to prove that AB is parallel to CD. First, circle the two given angles with 130 degrees. Then, we use a red pen to highlight the three lines which are related to this pair of angles. We see that this is an inverted letter F. According to the skill we introduced before, letter F represents corresponding angles. So we will use corresponding angles equal to prove that A, B, and CD is a pair of parallel lines. We will answer like this. Since angle PQB equals angle QRD equals 130 degrees. We have A, B parallel to CD. The reason is corresponding angles equal. One common mistake made by students in this chapter is that they often skip steps when handling questions involving two pairs of parallel lines. For example, in supplementary exercise 9, question 62. If we asked students to prove that A equals B, how will they do? Many of them will write down A equals B directly, with the reason corresponding angles A, H parallel to B, E. But we have to remember that, if we use the theorem of corresponding angles, we have to mark a letter F, which only involves three straight lines. But in this case, we cannot mark a F. So we cannot use the theorem of corresponding angles directly. In fact, we have to use the theorem of corresponding angles the first time to prove that A equals Y. That is, this green F. Then, use the theorem of corresponding angles again to prove that Y equals B. That is, this orange F. Then we can prove that A equals B.